Hey guys, so welcome back. Take a look at what we got here. This is a radio from a Chevrolet, a 1953 model I'm told, a Deluxe Two-Ten, similar to the Bel Air and the other models they had. It is a tube type car radio from about 1953. Looks like to me it's been cleaned up and probably refurbished somewhat. I don't see any rust on it per se. Maybe it's been repainted, I don't know. But we're going to take a look at it and see if we can get this thing to work. The owner that sent it to me has not even plugged it in because he knew it may have some capacitor issues and so forth. It has a transformer in it. So we're going to be careful with it and see what we got. I have tried to do nothing on this. I haven't even tried the buttons. I guess I'll try the tuner now, see if the tuning works. Tuning moves. It's a little tough to move, but of course I don't have a knob to get purchased with. So we'll see. I have a schematic. I believe it's this model here, 98668. This is out of Beitman's. I also have a shop manual for the repair of this that has it from 1954. I'm assuming it's pretty much the same. I'm going to start off with this one from Beitman's just to make sure I got the right layout, but I think it's the same. So basically what we have here, let's just kind of go through how the radio is set up. It has tubes, as you can see. It's not that different from, let's say, a 6-tube radio. You've got an RF amplifier here, the oscillator mixer section here. There's an IF tube. This is a detector AVC first audio tube. And there's an audio output tube. We have an audio output transformer. This line here would be the AVC. This line here would be the main B plus going to the tubes. We have 3 coils that will be adjusted since we have an RF amp stage. And of course, one of the things to know about this is that, right, this is a tube set. The plate for the audio tube is looking for, what does that say, 242 volts or something like that? How are you going to get that out of a car battery? You ain't, okay? Also, this is not a 12-volt car. This is a 6-volt car. So in order to get that, we've got to step up to voltages on this level here to get the plates here. This one goes, what is this one? That says 85 volts. This one says 200 volts. This one says 205 volts. 100 volts, it looks like. So we have to get the voltage up. So in order to do that, there's a transformer here. So this is not a series string set. So we have a transformer, we have a rectifier. The rectifier is a 0Z4. 0 means there's no heater on the cathode. It's a cold cathode rectifier. Now how do you get a transformer to operate? Well, a transformer requires alternating current. It can't work on DC. So the first thing that has to happen is that the DC 6 volts comes in and it goes through a vibrator. And what this thing does is it provides like a square wave as there's a reed inside that vibrates. And it goes back and forth and makes contact here and then here and then here and then here, and it's vibrating at a fairly fast rate. And what that does is it provides a square wave into the primary of the transformer that then allows the transformer to step up from basically 6 volts to, what does that say, 290 volts. That's a heck of a step up, huh? And then of course this will rectify it. And then we got some capacitors here to try to smooth that out. And then here's your audio output stage. Okay, so I would say what we want to do first is, chances are this vibrator may or may not be working, and if it does work, it may not last very long. So they make solid state upgrades for these that plug right in. I may look into putting in a solid state vibrator here just in order to make this a little bit less fussy to deal with and for it to play longer and have less problems. But before I order that, I think it'd be wise to go through and see if there was something wrong with this thing when they pulled it out. So we're going to check the transformer and make sure the transformer is okay. We can get into the windings on this by pulling the vibrator out. You can see it's in a 4-pin socket, and we can also pull the 0Z4 out, and then accessing these points within the sockets we can test the windings of the transformer to make sure they have continuity through them. May also go over here and check the audio output, make sure it's all okay. But anyway, let's open this thing up and we're going to head into the transformer by checking these two pin sockets as I mentioned. So we're going to go get into that now and we'll see if the transformer is okay. Okay, here's the dial light. It just pops off the top, and this just goes to a separate source for providing the light bulb. Tie it into the dash lights. It may even operate from a dimmer switch as well. I'll set that aside. We won't need that for a while. And then we're ready to get into this. Alright, so let's see. I can see that it wants to pivot off because it's engaged in these two clip locations in the back here. So it should just open up kind of like this. I felt it budge as I moved it. You can see here I budged it somewhat. Let's see. Can I tell by looking in here something? Well, it looks like the tubes are more available from the bottom here. Let me go after that. Same story here. You got two screws and the thing should open up this way. Okay. Let's see what we get. Yeah, here we go. We're in. First look. This is the way I expected the surface of it to look. A little bit more age, a little more surface rust. It's all in good shape though. I mean, it's fine. Okay, we're both looking at this together for the first time. How you like these devices for holding the tubes down in position? Yeah, so transformers in this case here. Here's the electrolytic, I guess, and here's another one here. Audio output transformer. The speaker is not in here. The speaker is located elsewhere. In fact, I don't have one to test it, so I'll have to get another speaker to use. Okay, there's the 6V6, so there's your audio output tube. See how this figures with our layout we have here. Okay, so here's our rectifier. Yep, I see it, 074 right there. So there's our rectifier. Audio output tube, 6V6, 6AV6, 6AB6, 6BE6. What's going on here? 1, 2, 3, 4, 5, 6 tubes. Well, there's another one up here. It's not shown on the picture because I see these are the two adjustments here and here. Okay, that would be, well, no, that's the detector AVC. I don't know, that may be your RF amplifier. We'll check it. Okay, so in order to get into the transformer, we need to check the bottom of this and this. Now, I can try to get in from the bottom by pushing that off, or I can also just maybe remove these tubes and go in from the top. So let me see if I can do that. There's a 6V6 out. Okay. There's our audio output tube out. Set him down. Then this is our rectifier here. Obviously there's no power to this, right? Let's see, so this radio is 69 years old in 2022. Okay, and there's our rectifier. Okay, so let me see. I like to make life easy. I'm going to try to go in from the below. That'll make it a lot easier for this. So I'm going to go over and come in from the bottom. Try that again. It just needs to be influenced. I'll bring you back when I get the top off. Hope you guys can see I'm trying to be careful. All right, now we're in. Somebody's been in here, all right? Somebody has been in there, and I've got their fingerprint. Gotcha. All right, I don't see anybody's handwritten notes or anything, but look at what we have here. We got 3 yellow jackets, we got an orange drop, and we've got a Chicon cap here. Audio output tube is here, and the rectifier is over here underneath this shield. Okay, I guess that's to keep the noise down, huh? All right, let's see if we can get in here. All right. So I stand corrected. This is not the electrolytic. The electrolytic's kept in here, I guess. But this is the vibrator. We just exposed it. Okay. Okay, let's go ahead and do the test we're talking about doing. All right, so let's check to see how our transformer's looking. Okay, here's the vibrator out. Volt replacement vibrator, made in USA. Is there a date code? Okay, some of you gurus out there that know date codes, maybe you can help us out with what this is. 52? 1952? I wouldn't think it would be a replacement, so maybe it's 56. Don't know. Okay. Okay, what I need to do is lift a lead. Let me kind of get my head in here and see what lead makes the most sense to lift. Okay, with that resistor lead lifted, we should be able to get an isolated reading of that primary right there. Well, that was certainly thrilling. I've basically been going through the schematic both from the Beitmans and from the shop manual, and this one's a little clearer, I guess. So basically within the transformer can that's all potted and tarred, there's only a few lines that come out. This capacitor is inside there. You can't get to it. But I can check here to here. So let's do that now. I'll switch back to this. Alright, so primary is from here to the lead that we connected that had the resistor going to it. Okay, so we're getting 0.4 ohms for the primary, so that seems okay. So let me put that down, find a pencil. Now what we can do is we can check the, I can't really get to the tap because it's all within this right here. But basically what I'm going to do is go over here, and now what I can do is check between the two plates of the rectifier to verify this winding here. So let me do that now. So one of the plates is here. It's actually on either side of this orange drop right here. And then, you can see that. And then this one here. Okay, can you see that? It's 800 a little over 800 ohms. Okay, so I believe the secondary is good. I think what I'm actually finding is this right here, and that is this disc you see right here. Let me see if I can get you in there, you can see this. It's a little bit different than what we see these days. It's like a chassis capacitor. So what you'll see here is you'll see a lug that goes down to underneath. Looks like it's underneath this round plate, but there's actually a circular mica disc there. I'm trying to get showing a little bit of reflection from the mica disc. Okay, so that's a capacitor, and then this is a lug that comes off that capacitor here, and there's three things connected to it. There's two of these yellow lines, and then there's this relatively new electrolytic. All right, and this thing here is 1,000 microfarads at 35 volts. It's not on the schematic anywhere. I don't know if perhaps the person who did this recap didn't realize that was a capacitor and thought it was missing when put it in, or maybe this capacitor is no good or it needed more capacitance. I don't know. I'm going to leave it in there for right now. I've checked the ESR on this capacitor and it's okay. It's very low ESR. It's not zero. It's not a short. So let me show you what else we have here. As you can see on the schematic, as you come off of this, you go across and you come to two places. One of them comes to the heaters and the other one goes to the switch. All right. So what we have here is we know that this one right here goes to the heaters because I can follow it over to here and it goes to pin 7 of the audio output tube. If we go to the audio output tube, there's the index. 8 is the cathode, 7 is the heater. So we verified that's the heater location. Now the other one, this one, comes up and goes to the front. So now what we're doing is we're heading to where the power comes into this thing. And this was an interesting search because I was looking for something like this. Let me show you what I have. So I have this, and what this is this contains a fuse. There's a fuse holder in here, and there's a stud looking connection on here. I was expecting this stud connection to be part of the radio, but I'm wrong. This goes off, I guess, to where the voltage regulator is or some other place. It actually attaches with this. So let me show you where that is. It took me a while to find this. Maybe when I show you, you'll see why. So the way the wiring on this is kind of shown in the manual is you'll see a couple of wires that come up and they're held by these little clamps. One of them is this wire and the other one is the wire that goes to the light that I showed earlier. Okay, the light comes up here and plugs in, but the power line continues on and comes on over here. Well, if you come over here and look for some sockets, well, let's see, I've got one here. That's your antenna. Okay, come around here, well, there's your speaker. I know that because I'm looking here and see it goes straight to the audio output transformer. So that's your speaker. So where's the power connection? Well, if you spotted it, it's that solder pad right there. So that is where the power comes in. So if I roll this around, get to where you can see in there, if I can. This is not easy for me to do. See, it's right there. So that is where the power connection comes in. It's soldered to that little tab right there. It's not connected to ground. If you look in there, you'll see there's a spark plate capacitor in there. So there's a sheet of mica on the bottom or some kind of fabric. Then you've got where that wire is connected, then there's another one and there's a plate on top, and all of it is held down with a clamp with a piece of insulating material over it. Alright, so what I've done though is I've traced it from that location over to the on-off switch, which is in there. Okay, you see there's some other new yellow jackets in there. So the on-off switch positions are here and here. And I was able to verify the line from the cord comes to that one at the top, if you will. It's actually at the very bottom, but that one there, and then when you turn it on, it connects to the one below that. So there's your on-off position. By the way, while I have it, here's a good view of where the antenna comes in, and here's your antenna trimmer. Okay, so that's where the power comes in. I believe we've tracked down what's going on there. And I believe based on those tests we just looked at, the transformer is probably going to be okay. All right, so now I guess the point is should we maybe go to power up? Because you look at this and think somebody's been in here, they've done the capacitors, there's no paper caps in here. Well, I wanted to check the electrolytic. I thought that this was electrolytic and they've left it in. I was wrong about that. So let me see where the electrolytic is. Okay, here's the electrolytic here. And looks like to me the original electrolytic is still there. Yeah, original electrolytic is still there. So you got that 1500 ohm capacitor going between the two positive legs, and then the other side of that goes to ground. So this would be ground. I see a orange drop hooked up here though. Okay, if that's ground, there's probably a lead that comes over here to this tab under these wires. So if that's the case, this orange drop runs over to the audio output tube pin 1, 2, 3. Pin 3, 1, 2, 3. No, 1, 2, 3. That's the plate. So is there a capacitor from the plate to ground? Could be, huh? I don't see. Yes, there's a capacitor that should go to the cathode, which then goes to another electrolytic that goes to ground. So then this is the electrolytic. So there's three parts to this. That's a 3-part electrolytic. And I guess the ground is the chassis of it. We check the ESRs on that guy. Okay, so let's go from ground. I'll pick it up here from this resistor to the one that's got the orange drop on it. 3 ohms. The one that goes to the striped side of the power resistor is 0.5 ohms. And the one that goes to the other side of the resistor, 1 ohm. So the one to the orange drop is 3 ohms. A little high. I'll check to see what the allowable ESRs are for this. I'm sure we're going to recap this. Okay, so I think we're looking pretty good on this. Now what I'd like to do is do a quick check of the audio output transformer to make sure it's okay. Alright, so we can do that by looking at the pin that goes to the speaker, to the chassis, and see if we've got some resistance here. Let's see, that won't be a short. So that should be a fairly low resistance. So here's the audio output transformer right here. Here's the speaker output. It's here. So I should be able to test from here to ground somewhere. That's not a probe. Good, we got a 0.5 ohm. So the secondary is fine. Okay, let's see where we can pick up the primary. Okay, we can pick up the primary between the cathode, pin 8 of the rectifier, and the plate of the output tube, which is pin 3. Alright, the cathode of the rectifier is pin 8. This is the rectifier. Pin 8 is here. And then, so that's this line here. And then this one comes from pin 3 of the audio output. excuse me, audio output tube. 1, 2, 3. All right. That's also got that capacitor that comes over here and goes to the electrolytic to ground. So that's that capacitor electrolytic to ground. Okay, so let's check the resistance there. Woohoo! 400 ohms. So our output transformer is okay. All right, so I think what we're going to do now, let's look what we got. So we think that this is doing pretty good. We think this is good. I think what I may do now is just see if the vibrator will operate. I need to put that resistor back in. I've tested it. It's a little high, but put this resistor back in, and then. But what I'm going to do is just operate the vibrator just on the bench. I think I can hook it up to a. Well, let's see. Do I have enough voltage to do it? I'm not sure how much voltage to put into it. Well, I'll give that some thought whether I want to do that or not. But then what I'll do is, then whatever I do for here, if this test's okay, I'll put it into here, and then I'm going to leave the rectifier out. And then what I'll do is bring this up slow. I know I have to have enough voltage on it for this to operate. But then see if when this kicks on, first of all, do we get a short to ground from the transformer? We'll catch that on the dim bulb. And then also what our voltage is coming to the plate of the rectifier. It looks like it wants to be 275 volts AC across the plate. And then if that works, then we can check it, putting the rectifier in, and see how we do. I've checked the ESR of these electrolytics here. They're actually reading okay in terms of ESR, which is low voltage, very low voltage in fact. So I don't know how they're going to operate. These are both rated for 400 volts. This is quite a bit less, but we don't know how they're going to behave. But as long as they're not a short, then worst case we'll probably just get some hum out of it or some reduced voltages in the circuit. But then we may find ourselves trying to see if this will play. But let's don't get ahead of ourselves. Let me think about what I can do about this. If not, I'm just going to put it straight in and then come up slow and measure the voltage across the plate to the rectifier socket with the rectifier not in. So let me pursue that and I'll be back in a sec. Okay, so yeah, I've been looking at this. I've testing the vibrator out, and I don't think I know how I'm going to be able to test that just laying out on the bench, because it's getting its power through the center tap of this primary. I'm just not going to do it that way. I think I got another thing I can try. I'm going to try to use my component tester to see if I can see the coil through here. There won't be any connection here because the points aren't touching. But one of these legs should go to ground through a coil, and I should be able to see that with the component tester. I'll see the inductance of it. While I'm at it, I may check to see if I can see the inductance of these too. I can take a look at that. And then what I was thinking about doing is putting this in, bring up the voltage slowly on a power supply I have. It doesn't have the juice to run this whole thing, but each one of these things is going to take about an amp to run the heaters. So what I thought I would do is pull the rectifier, and then, like I say, this will pull some current for running the heaters. So I think what I'll do is I'll pull the tubes out so that none of the heaters are getting any voltage. So then what I could do is basically whatever kind of current I can muster at 6 volts just to run the vibrator. If it's got enough, maybe I'll be able to see some voltage out of the transformer. So I just thought I'd give that a try. I don't think it could hurt anything, so we'll give that a try. So let me get my component tester set up, and then we'll take a look at this part of the vibrator, see if we can see the electromagnet. Like this. I'll clean these contacts too. That was really dirty, as you can see. That was just from the contacts from the pin. Okay, so what I'm going to do is go one leg, this will be ground. And then this one here will be, I'll just take this top one. Let's see what we get. Hey, look at there, we got a coil. 44 ohms, 8.3 millihenries. Okay, good. So we've got an electromagnet. I want to see if we can see, see if we can see the primary. Let me get this flipped around. Okay, so the primary was on either side of this resistor, which I've put back in. I had lifted that earlier when I was doing resistance measurements. There's our primary, 1.1 ohms, 0.02 millihenries. Okay, what about our secondary? Those have quite good contact. But I know I had 800. Well, there we go. (811 ohms, 25.6 henries. Yeah, we got ourselves a big step up here, don't we? Okay. I'm going to put this in, leave this out, take these guys out, and then hook up 6 volts, well, a 6-volt power supply that I can bring up slow and see if this thing starts to operate and see if we get any voltage out of here. And then we'll see what we get. I'll bring you back when I get all that set up. I got to pull some tubes and stuff. So these come off by pinching them in and just popping them right off. That's pretty cool. Okay. So let's check our tubes that we got where. So we know that we pulled the audio output already. That goes there. This is the 6AV6. This is the detector. AVC first audio. 6AV6. Okay, good. This one here is the IF amp. It's the 6BA6. Good. It is a 6BA6. Hey, sometimes tubes get put in the wrong sockets. I've done it myself on this channel live. Okay, this is, I didn't make that happen. This is the converter tube, you might call it, the oscillator. Let me turn that off. This is the 6BE6. It's the oscillator and mixer. Let's see, that should be the 6BE6. And it is 6BE6. And then this last one here, I'm going to believe is going to be the RF amplifier. It should be a 6BA6. Come on. Come on. Nice and tight socket, that's for sure. Good. And 6BA6, very good. Okay. In order to make it easy to get to the positive connection on this, that connection, if you remember, was buried in here. So what I did was I pulled the vibrator out so I could get access into there, and I've soldered in at that point down there. You see a power line that I can use for hooking up for testing, and I put some shrink over it so it's not going to get accidentally touching the side if I get to pulling on wires or something. So anyway, that looks like that's about ready to go. Put the vibrator back in. Vibrators in. Okay. So we have all the tubes out, including the rectifier. So now what we're going to do is hook up and see if we see anything coming out. So I'm going to get that all set up, and I'll bring you back when I get all the leads hooked up. Okay, I'm set up to run the test. I've got the outputs from here hooking up and going to the power in here. The negative is hooked up down here, and it's attached to the stud in the back here. I've got this voltmeter I'm handling right now is going to be reading the DC voltage going in, because we're going to lose some voltage to the bulb. So this will show one voltage figure, but some of it's going to be lost here. So this will be showing what's actually going into the unit. We may need to end up bypassing the bulb once we get satisfied we don't have a cold short somewhere. And then I'm set up also to be able to then read voltages over here with this probe here. So I've got this connection up to chassis ground here, and as I say, we can go through and maybe check some voltages. Alright, I think we're ready to roll on this. So let's take some time here to think about what we're doing. Okay, so we're going to bring the voltage up slow, and we're just going to see if we're getting anything out of the rectifier. So in order to do that, or rather out of the transformer. So what I can do is, actually what I want to do is have this hooked up plate to plate, don't I? So I'm going to go over here and hook this up to plate here, and this is going to be hooked up to the plate here, basically on either side of that orange drop. Okay, so we're measuring the, so we're going to put in voltage here. It's going to come in here. We're going to bring it up slow. I turn the switch on, and I've got all of the tubes pulled. So this is an open circuit. It doesn't go anywhere. Okay, it's going to come into here. It's going to go through this inductor inside this can. It's going to go in, and it's going to go into the the tap in the middle of the primary, and then we'll see if it'll operate, if I've got enough power and so forth to operate the vibrator. If I do, then we'll start to see something happening in the transformer. We'll see that come out where I have this one here hooked up to measure voltage on either side of that capacitor, which will give us voltage across the full winding of this. And we're going to go for this target voltage here, which is what, 280 volts. I'm assuming that may be to ground, so it could be double that from here to here. And then if we get that, then maybe we'll put in the rectifier and see if we get this out. But this will be AC, so we'll check that first. Okay, I think we're ready to go. We'll see if the vibrator works. Okay, so we got the voltage started off at 0. We're measuring 0. We're in DC. It's going to be an AC. That's what we want. Okay, power coming on. Okay, turn it off again. See if we see anything happening here. I don't believe the vibrator is running. So let's just see what we did when we bring it up. There's 1 volt. I'm looking here at the actual voltage. It's not moving any current really, so I'm not losing much in the dim bulb, so these are pretty much agreeing right now. I hear the vibrator running. I turned it off. See if you can hear it turn on. Vibrator's running, guys. Oh, look here. Turn that off. It's off. Okay. Isn't that a miracle? Alright, so here is DC voltage. Here's AC voltage out of the transformer. You'll hear it kick on, and then watch this. It's running. 420 volts. We're at 4.5 volts going in. We're running a half an amp. I'm just going to let it sit there for a minute. Still at about a half amp. It behaves like a capacitor's chart is forming, doesn't it? There we go. 6 volts, 0.55 amps, 625 volts AC out of the transformer. We got a good transformer. But I'm going to let it run for just a bit, and I'm going to check to see if the transformer's hot. And then if everything seems reasonably okay, then I'll bring you back. We'll talk about putting the rectifier in and see how we get there. Let's see, do we want to check both sides of the winding? We could probably do that if we wanted to. And from that plate, go to ground, right? Is that right? If I go from one of these plates to ground, that'll be checking the center tap. So let's see what happens. .300 volts. They're supposed to be 280 or 290. I can't quite read what that says, but I think that's pretty good. I don't smell anything. I'm going to shut it off and then see if the transformer's warm. Pretty cool. Transformer's cold. It's good. Well, you know, it hasn't had much current running through it, right? So it should be. Okay. Let me find the rectifier and get set up for that, and we'll come talk about what we're going to do there. So let's see. We're going to want to go measure from ground to pin 8 of the rectifier tube. Alright, pin 8 of the rectifier tube is cathode. Okay. There's where I'm picking up ground. This will be DC now, since we're on the other side of the rectifier. Okay. I think we're ready to go. So we've got all the tubes out, but what we're going to do is now start getting current out of here. So we're going to see current going to the capacitors, and we're going to see it go through here, and but there's no tubes in, so I'm not going to conduct anything, but I will get voltages on plates. So let's just see what we get. See if this thing can put out enough to run everything. We'll see. So this is in DC, cathode DC output. Helps me turn it on. This is the voltage going into the radio. Okay, I'm not at full voltage. I'm at 4 volts. So I'm at 177 volts DC out of the cathode. So our rectifier seems to be working. Right here at full voltage with all the loads in, we should be getting 255. I'm just going to let it run there. We're at 0.7 amps, by the way. I'm going to let it run there for a bit just so we can kind of, you know, see how it works. Because like I said, we're getting voltage to the big electrolytic in here, and it may need to do a little reforming. So I'm just going to let it sit there at 200 volts for just a little bit. It's climbing already, right? 255 is what it's going to go to at 6 volts. So he's climbing, it's reforming those capacitors. Current's at 600 milliamps. Okay, I'm about where I want to max out, and back it down just a little bit, because it'll still continue to go up. But I'd say this is a successful test. I think our power supply is good. So we check a couple of plates. I'm not going to write them down because they're not, you know, with everything populated right now, but it'd be fun to just kind of go through and see. So let's see. Now let me make sure this is stabilized. And it's still climbing. Let me let it sit here and get up and get stabilized. I'll speed it up. Okay, that's looking pretty good. I'm going to go ahead and start checking a few plates. I can see why I use a long probe, right? Okay, so this is the output tube, and the plate of this is 1, 2, 3. Yeah, that's where this orange drop is. Let's see what we get here. Once 242, we're at 248. That looks good. The next one over is the screen. Let's see here. Should be the screen. 205 for 244. That's pretty high. Am I still okay here? Yeah. Let's see, this plate here on the detector is here. Which pin position is that? It's not showing the index. I guess it's 8 as well. I think the detector AVC is this one. Let's see, is that the plate coupling capacitor? Let's see, it should come from pin 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's the plate coupling capacitor. Am I getting anything through that? No, that's good. If we go on the other side of that, it should be the plate of the detector AVC first audio tube. 235 volts. It says here 85. So we may need to, well, when we start pulling power, we'll see some differences, I'm sure. Okay, so let's see, 200 volts on the IF. Which one's the IF? I think it's this one. Oh, yeah, of course, there's not an index on these. These are missing. No terminal. Okay, that makes sense. That makes sense. Okay, so let's see, this is going to be 1, 2, 3, 4, 5. I think this is it here. 1, 2, 3, 4. Is this it here? Maybe. 240 volts, yeah. And then this one is 1, 2, 3, 4, 5 as well. And the next one's 1, 2, 3, 4. They're both 5. Okay, I think it's going to be okay. I'm not going to try to get my head up in here right now. But go back and see how we're doing on the cathode. We've stabilized pretty well. Okay. So the problem we've got is this is at 0.6 amps. This won't put out enough power to drive all the heaters on all of these tubes. So I'm going to have to come up with a different power supply solution. But meanwhile, the power supply seems to be in good shape. Very encouraging. Okay, so I'm going to pause this project to get another variable DC power supply, which will be another project. So unless you're following along, refer to the playlist to jump ahead to the next video in this series. Thanks. See you later. Bye.